To CELT's Innovation by Design Project-Based Learning Workshop, Workshop number 2. In this lecture, we're going to talk about developing a framework for a project-based learning course. We're going to look at different strategies that you'll be able to do to kind of develop it as you go along. The first part of this course was an interactive, hands-on method in which we actually worked out one of the exercises you'll normally find in a project-based learning course. A brief was given, and people worked together in a collaborative fashion to propose one particular type of small course assignment. Those watching online, of course, won't be able to participate in this, but you will hear me address it in the first part of the lecture. This lecture for workshop number 2 is in fact in 2 different parts in order to break it down into slightly smaller pieces. And if you're interested, please look at workshop number 1 lecture as well. In today's presentation, we're going to talk about developing the project-based learning framework, ways of thinking, making, and breaking it down so that you can plan and create and enhance your project-based learning framework. The first part of this workshop, we participated in an in-class exercise. I had sent out an assignment ahead of time. The theme of it was the future of food. In it, I'd asked participants to imagine themselves in a role-playing mode in which they'd be teaching an honors elective course, a 2-week module. I'd asked them specifically to work on a discovery, empathy, and research portion of a PBL class. Asked them to think about what they would do in terms of making an exercise. So I established a set of clear deliverables that the team was going to establish a subhead theme underneath the future of food, one that reflected the interests of the different disciplines that were participating in it. 2, that this group would tell a story about how the project would be introduced to the course. 3, that the groups would create and share their proposal for one of the activities. This could be an overall activity, or it could be one in which there were several sub-activities within it. Finally, the groups were asked to create and share their proposal for what would be acceptable artifacts at the end. The reason it's called a design sprint is there were actually 30 minutes total. Now in this, I had particular instructions for self-reflection time. By emailing it ahead of time, people were able to think about it. Then there's 3 minutes, and there were certain prompts that were ways that the individuals could think about their contribution. Then there was another set period of time in which they were supposed to share their individual contributions with each other. And then finally, another deadline in which the groups were asked to move towards the production of these deliverables. And after 30 minutes, 12 participants were able to share from all sorts of disciplines, were able to share 4 particular proposals. The interesting part about going through a process like that is this idea of learning by doing. And learning by doing, it makes it so that some of the information that we had covered in workshop number 1 became a little bit more real. So, for instance, does the future of food meet the essential elements for project-based learning projects? So I'm showing you the PBL works, or the former Buck Institute works, the overall essential standards for a project-based learning course. If you recall, it starts with a challenging problem or question. It has to have a level of sustained inquiry, meaning it's challenging enough. There's an authenticity to it. Participants are given a voice and choice. They reflect on what they've done, and they have a critique and revision that's part of a public product. We know that both future and food as themes definitely would have to have a sustained inquiry. Those are so wide open topics, they would require a longer inquiry. Authenticity. No matter who you are, you understand food. No matter who you are, you have the passage of time, past, present, and future, that you're aware of. And so immediately it authentically tied into people's experiences. Asking them to create subheads, asking them to create activities, gives them choice. Reflecting on what their own contributions was the other part. Critique and revision was the teamwork, and then making a public presentation. Is to show you that within 30 minutes, you can do an effective PBL project, at least the beginnings of one. And I'm also showing this to let you know that this is a way in which your students could also learn the PBL process. So what else have we learned so far in both Workshop 1 and now Workshop 2? In September, we learned about the qualities of the project-based learning course objectives. We learned these essential elements we talked about in the previous slide. We learned about developing guiding questions to help frame the projects, which we see under there in the course design, and how the project itself is defined. We learned about the backwards design process as a way of starting from the end, imagining then what the final artifacts or evidence might be, as a way of then working backwards, back to then the guiding question. So our goal today is to discuss this middle portion, the course planning and scaffolding in greater detail. First, let's take a look briefly at this graphic and see what we can learn from it. We realize as the semester begins, there's a certain amount of work that has to happen ahead of time. You see that over on the far left hand of the slide. But then as the semester begins, the first phase of it is generally this discovery mode. And the discovery mode is what our hands-on experiential project was all about. At the end of that, there's a module, and then that work that's been discovered is interpreted. The end of that module, then ideas are created. That module ends and those ideas are tested. And eventually it's down to the very last in which it's finally evaluated and presented. Well, as we demonstrated in just a 30-minute exercise, whether it's a long or short process, either a semester long or 2 weeks or even 30 minutes, the project-based learning process works in terms of learning. Now, I wanted to point out when you look at the Kolb model and this idea of an interactive exercise in which you reflect on some things and you share them with people and you have a broader discussion and you present them. It starts with feeling and watching, down to thinking and watching as you interact with your team, thinking and doing as you generate ideas, and finally feeling and doing as well. And there's always this back and forth between active experimentation and concrete experience that happens within this format. It's an accelerated experience for sure, but it still works. Now let's look at the higher order thinking. Given this particular proposal, there's a remember, an ability to recall how to make an assignment. You understand what the assignment is asking you to do, is ask them to apply their expertise and their disciplines. And finally, when they started to share it with others, there was an ability to analyze and evaluate, and essentially then as a group, they created. So there's a facility involved with higher order thinking, particularly with people who are able to do it often. This slide was included in the first lecture series, but I'm showing it again here. Why? This is an example of the retrieval practice, one of the classic project-based learning tactics. It takes passively absorbed information, in other words, these graphics that were shown to you in the lecture, and tries to embed them with more knowledge and understanding because there's a retrieval process in which you were shown it once, and then you experienced this process, and then you were shown it a second time. So this retrieval idea, being able to look at these slides again, is your ability to hack into the recall of it. Oh yes, that's right, I remember the higher order thinking. Whereas if you were just shown the slide once in a passive environment, or simply experienced it once, you wouldn't have that full combination of experiences that help with the retrieval. In fact, while we're talking about teaching tactics, I also wanted to point out that the PBL process just in these workshops. In gray are the things we did in workshop number 1, the different tactics of the active learning and inductive learning and backwards design and case studies, and even coached ideation. And today we're going to do some retrieval practice, as you saw, experiential activities, guided discovery. We're going to look at learning artifacts and the cooperative learning. You can see the value of having interactive course activities. You set up these particular activities in a way in which you know that these tactics and these learning experiences are going to happen. When you are intentional with your assignments, you can provide these opportunities. The other important objective with this workshop is simply to show that project-based learning creates an inherent value of intrinsic motivation. Your participation in watching or being a part of these oftentimes comes with just through your own intrinsic motivation. It's your act of doing something without any obvious external rewards. We're hoping that students do this work because it's enjoyable and interesting, rather than because there's an outside pressure to do so. When they can personalize the learning, they see the challenge of it. You set the standards high. I believe you can do it. Again, I'm pointing this out because this is the tactic I had used in creating a design sprint. Now, a design sprint in which people who haven't coordinated on a project are asked to think through and produce a project all within 30 minutes is, on its face, challenging. And yet, because they're all working towards this common goal, there's a motivation to do so. There's a satisfaction in the challenge and the meaning of the work that comes through. This then intrinsic motivation is something that you can do with your students as well. Ask them to complete things on a particular deadline. Show them the value of what they're trying to do. As we come back to this diagram, the idea for our PBL coursework is to establish a scaffolding. And the key thing is that it starts over here on the left with a broad set of options. Before discovery begins, you're not really sure what the projects are going to be. You have a general theme, maybe even some sub-themes, but you're not really sure what direction it's going to go. So in other words, it's a wide. And then you get to the discovery process and you're asking students, in fact, to increase their scope. Once you get there, we can't continue to have that expand. We have to narrow it. So it narrows through the interpretation range. From there, the interpretation range has already got a smaller range of potential options, but then the ideate option means we're going to expand a little bit more. We're actually going to generate some ideas for how we can actually create things in this process. But once you've created a different set of options, you need to test those. And by testing them, it narrows it once again. And eventually, when you get to the whole evaluate or breaking part of it, the public presentation part at the very end, what you've found is that the options are much more refined than they were at the beginning. The other reason I'm showing you this graphic is to show you the value of when you stop and take time in your particular course to show a graph and a graph that might in itself be able to provide information. So this is an example of the cognitive tool. These are cognitive tools are representations that help learners see a pattern in information and make connections on their own. Now, when I look at this, I think that there's other opportunities to use different representations that maybe spur different thoughts in your mind about the project-based learning process. I enjoy this one quite a bit. And again, you can see that it has similar phases as the previous one of the discover, define, develop, deliver, evolve. We can also see that it's got the same trajectory. Starts here, expands, narrows, whoop, who knows where it goes, right? The other reason I like this graphic is because it's a simple graphic in terms of the line and the workflow. And yet below it, what you can see here is a very easy to read set of tactics that both students and the teachers can participate in within each one of the phases. In the process, in the discovery process, the teams already came up with ideas for immersion, active learning processes by which the students would learn about food by immersing themselves either in buying or researching it, questionnaires and how they would find out information, interviews with people about food or the future of food, self-documentation, and part of this had to do with mapping, meetings, basically getting users to look at their own experiences and make observations about it. And with that, quite a few groups also got into some of the define phase of it in which they're asking the students to tell the stories, find meaning in their work as well. So again, I would really suggest that you start to show some of these graphics to the students and to your other instructors as a way of really trying to get all on the same page with how this process might work. So what actually happens then? If we were to break this down into a more direct linear idea that there's discovery, ideation, experimentation, and evolution, what actually happens in the discovery phase? Well, one way of doing it, and especially this is a great way of being able to show students who are inexperienced with the idea of generating ideas, is using something that's called a visualization of systems thinking. Systems thinking is a way of trying to understand a much broader set of topics, a much larger set of systems, but to be able to visualize, at least in one's own perspective, how they see those systems. So there's a complexity and interdisciplinary nature of problems used in PBL courses. Participants have to have an understanding then of systems thinking. So systems thinking is trying to understand how constituent parts interrelate and influence each other within a whole system. So systems thinking and the various ways by which it can be visualized, in this case, sketches, but of course it could be qualitative and quantitative, it could be causal loop diagrams, behavior over time models, simulators. These are obviously much more advanced ways of visualizing systems thinking. But they all serve to create a common language that connects interdisciplinary teams. In this approach, I'm showing you something in architecture that I used in an architecture course. Students were to design a space for mindful living, and part of the mindful living I proposed was about the consumption of food. This exercise, I should mention, is based on the How to Make Toast proposal by Tom Wuchek. Tom Wuchek's got a whole website promoted to this. He has thousands of different examples of the way people have been asked to just simply draw how to make toast. So when I start, I give them a phase 1 of this. Identify the systems, consider the process of what it is to make toast. The second part of it, after just a couple minutes, they share this information with each other. And of course, it's a bonding exercise and it's kind of humorous to see how people draw. But in the second phase, you ask them to take the systems part of it a little more seriously and say, okay, expand this. Can you introduce maybe a disciplinary perspective in this? If we're looking at this drawing in particular, you can see that this student looked at where the food came from, how they got it, how it was packaged, how it was unpackaged, the process of cooking, waiting, buttering it, consuming it, and then putting stuff back away and leaving the house. From this, the student actually realized that food was something that they had to go get, and it's something that made it so they could then leave the house. So in their design and for their proposal, they really looked at this coming and going process, and that the food itself wasn't just something that stayed there, but that the food was part of a much larger system that involved their participation, not just living within a house. The third phase of it, and this one gets really interesting, is where you ask them to think about the opportunities and threats. Now, what threats are there in eating toast? If you think about it, you can immediately get to issues of food scarcity or resources. Other students then started to draw items about fair labor, economics. So something as simple as eating toast. Within a matter of about 20 minutes, these students started to be able to get the systems thinking, to get a much broader perspective about where their food came from. What I like about this process is these are simple exercises, they're fast exercises. You bond with each other over the exercises and the sharing of the diagrams, and it generally makes for an amazingly profound first class to be able to talk about the discovery process. What else happens within this first phase? Well, you want to think of it this way. If the assignment is that there's a discovery in which we're trying to do empathy and research, the assignment is something that is emailed out. There's a delivery. When I talk to you in 2 days, I'd like to see this. When you're talking to the students, there's this prompt or this teaching activity. And they're saying, I don't really know. This is kind of what I have. Your job as a coach and a facilitator is to have different prompts that you think would advance their work along. So what could these prompts be? Well, how are you joining a conversation about this topic? Have you found something missing within this systems thinking? Are there ways you could see that you might be able to improve this incrementally? How is this knowledge that you found actually fitting within a larger framework? And as they come through this, they learn to be able to address those things in their presentation. And then the module itself ends, and they find themselves not just with a series of random pieces of information, but in fact with an attitude about the work that they've uncovered. What do you get out of that? Case study knowledge. You're teaching them to research. Ideally, if the exercises are right, they develop a certain set of empathy or perhaps cultural competency. The best portion is that they understand that there's a confidence and enthusiasm in their work. Yes, it seems like that's the right idea. I know that this is open-ended, but for sure, keep going on this path. If you set up the exercises right, there's a situated learning part of it. This also has to do with student voice and choice. And finally, as you're trying to then narrow the options from here, the end result of the discovery is that there's a problem definition and a project direction that become evident. When students have this open-ended approach, oftentimes they're not sure what to do. Do I look online? Do I Google it? Do I go to the library? But remember, project-based learning guiding questions are not something that can be answered by Google. It's a much more interpretive thing. This way of trying to put together and analyze broader set of information and systems takes prompting and coaching. So one thing I often do is I'll create a form or some other method like a Google Doc or online Canvas discussion by which students check in. Somehow on it, you can't let them just go for a long time without checking in at all. They need reinforcement, direction, and prompting. So one way of doing it, perhaps, is that you have a sub-assignment within there. Okay, in the next 2 days, I'd like for you to have 2 topical research sources. One source has to be from another discipline than yours, so every student or student group will share with the larger group. They'll summarize and they'll have a verbal description. Or perhaps they'll just lead a discussion. Maybe 2 days after that. Okay, I want you all to find a conversation that's already ongoing or a research mode that's already ongoing. I want you to identify efforts similar to your particular proposal. Who's doing it? What are they doing? Why are they doing it? I want you to collect some images and information and share this with the group and how it complements your work or differs from your work. This discovery process has this prompt and check-in and teaching, but it also can have other smaller discrete deadlines. These can be rapid, fast deadlines to do. It still joins the larger trajectory, but it's a discernible and easily understood task ahead of them. I'm going to show another example of an actual project-based learning project based on food. This is based in the Worcester Polytechnic Institute Great Problems Seminar Program. Information about WPI was in our workshop #1 lecture and of course online, and I definitely encourage you to learn more about the GPS program. This one I'm showing you is under their topic of food sustainability. I should mention that this is for first year students in their GPS program. So it's a 2-week project, again, showing that project-based learning can be a smaller scope of work. The idea was to introduce the first year students to issues related to food. They were asked to visit a local food vendor and restricted to $90 a week to feed a family of 4. They were assigned places to go. What were their prompts? You can see here that they asked them to think about where their food came from, why it was priced that way, how they got to the market, where markets were located. Then what value did your group use to determine what food to select? This gets to the heart of some really very interesting questions. Is it about budget or availability or broader ethical or philosophical framework about food? In it, these are authentic questions in which the students have to work collaboratively together. They have to decide on something as a group. In it, they find their voice and their choice. Where's the money you spent actually go? Who benefits the most from your purchase? How'd you determine nutritional needs? Now, in it, their artifact was only a 1-page paper and a verbal presentation. I think this would also be interesting with opportunities for maps, photo collages, other ways of maybe representing these very, very, very difficult topics in something more than just a 1-page paper. What's interesting about this particular assignment, and in fact the prompts of the assignment, is that when you start to think about feeding the world or food sustainability, we realize how many disciplines touch a topic like this. Biology, genetics, ethics, economics, fair trade, labor, food waste, And so one of the main issues is this question of, well, that stuff may be out of my scope of expertise. What should I do if that's not something that I'm comfortable teaching? Which also brings us to this question. I recognize the benefit of interdisciplinary work, and I recognize the value of some sort of open, student-led research in PBL, but how do I also bring it back to a certain level of disciplinary specific knowledge and skills? In other words, when we ask those larger questions about food and food access and food security and food sustainability, how do we make sure that if there's a particular set of applied knowledge or skills that needs to happen, that we can make sure that it actually is part of the course? The secret to this is doing problems within projects. Now, if you recall from workshop number 1, the distinction between problem-based learning and project-based learning is what's demonstrated here in this particular graphic. Both of these have a certain set of open-ended solutions that are plausible, but the distinction, of course, is that problem-based learning has a problem that is in fact selected by the teacher, a range that's constrained by the teacher. Let's look at the example. How can we introduce this particular genetic strain of crops to a new region? Now in it, the assumption is that that's what we're doing. We're introducing a genetic strain of crops. Where? This location. So the only thing to answer is a whole series of things like how. Now within that how is a whole different range of possible solutions and great application of disciplinary specific knowledge. Where project-based learning may take a broader theme such as food safety and security, and instead of asking one particular problem to solve, it might ask broader problems. Why isn't food safe? What makes food secure? Who's hungry and why? If you had a theme like what makes food secure, perhaps within the discovery process or the ideation process of that, you could also introduce a problem. As you're looking for what makes food secure, you mentioned food access or security. This could be something that you might say to your students. So because you've already looked at maybe the access to food, what we're going to look at is, could genetically modified food help bring crops to a new region where they currently don't have food? The answer may be yes. Great. Here's the problem then. Try to demonstrate how this particular strain of crops might work. So the problem fits within the project. Now, this may make some people uncomfortable when they think about all the different disciplines that are associated with project-based learning. Because, of course, faculty are specialists in a certain type of disciplinary knowledge. PBL courses, by design, may address transdisciplinary topics, biology, history, public policy. For instance, I'd be pretty good teaching a class about architecture, but I wouldn't be very good at all in teaching a class about public policy. So what happens in examples when I'm teaching a class and public policy topics come up? Well, the thing is, you accept that. You accept that you're not an expert in public policy. You're not expected to know about all of those fields. Instead, you frame the class as a collaborative learning process. The faculty can then learn alongside the students. So if a public policy issue comes up, I'd be able to provide the guidance to the students to say, how are you going to find information on that? What are you learning about the public policy? Now, of course, I'm going to reach my limit of expertise pretty quickly, as will the student. So in that case, I'd invite in experts. I'd ask them to collaborate with people who are actually doing that research, putting them in touch with someone that might be able to answer their specific question. And I think that what's interesting, and these are some quotes from people at WPI that have done these projects. What's interesting is when you think about how that process of learning comes about, you as an instructor can feel free to experiment with these methods. When you learn alongside them, you're teaching them a process of critical thinking and research. So instead of thinking about that your teaching is only about a topic, your teaching can be about a process. These soft skills, learning to communicate and research and gather information and synthesize it and apply it, these are of course all the higher order thinking skills. And when you do that next to or in conjunction with your students, it has a profound effect on their learning. Finally, as we're looking again at the PBL mapping, the workflow, and the visualization, we find out that some of these things that I've been mentioning in terms of the different disciplinary approaches, or even the way that discovery can branch out into different directions, this diagram simply doesn't do it. This, I think, is a more accurate workflow of a PBL process. In this, again, on the left, you can see where it all comes from, which is a project-based learning planning. This has to do with all your essential elements of the guiding questions and purpose and learning goals. This is work then that you've brought to the course and to the course assignment. Once you do that, you understand that the different project teams will be taking these in different directions. So, as the interactive exercise today had one prompt, immediately the 4 groups each took it in a different direction based on who was involved with the group, their discipline, their expertise, and even their interests. Each group will go through a discovery, ideation, experimentation, evolution process. The other thing I wanted to point out is as we go through the very middle of this, we see that as the project is introduced, that perhaps there's some training to get people used to the idea, both students and faculty, of how the PBL process might work. Once the discovery process happens, we're in, of course, the Bloom taxonomy here of the higher order thinking. We start with understanding. In the ideation, they learn to apply and analyze the work. In the experiment, they evaluate it and they create, and eventually it evolves. Now, between each of these phases, there's also a couple things that you as an instructor have to realize. First, you want to make sure that there's a deadline, a review, some sort of way of being able to adjust the module. Be able to say, we're done with the discovery process, mostly. From there, you can make assessments. How did that go? More than just prompts, but actual guidance. It also allows you to create additional lessons for future phases. This happens then after ideation, after experimentation, and each time when you have this public presentation and a review, we're now having to synthesize more and more and more information, which means that you're going through the Bloom taxonomy of higher order thinking over and over and over, rapidly enough that you're actually creating critical thinkers. People are able to produce work based on that critical thinking. When you're done with the course, you start with one topic, but when you're done, you're going to find that you have various proposals. And all these proposals, in fact, all get at a common purpose. My favorite part about that is that when you start the course, if students think that there's one right answer, it doesn't take long to figure out that all of these different directions are valid answers. And in fact, that being a student or being a professional doesn't mean that you're supposed to have the answer. The world is a super complicated place, and there's very complicated problems. And when you see that different solutions exist that all are created to address the same kind of common purpose, it really establishes people who are ready for the complicated world in which they're going to emerge. And finally, what I've found through this process, and when there's a common purpose to the work, that the work never ends with these proposals. It either continues with further research, future careers, community engagement, and ideally, what you might find is this also reverberates throughout your curriculum. They get interested in a particular topic, they've researched the topic, they're invested in it, but they're not quite done with it. And so then you're going to find that this continues throughout their educational career. And this, I think, the reason I drew this was to provide you with a map. And this is my last topic about the cognitive tools. This map will allow you to actually think about how you would fill in these gaps, how you would create things within the discovery or ideation or experimentation process. In the next lecture, we're going to talk about more specific tactics for planning your course